Okay, guys, I wanted to make a video just so I could actually show you some pictures that go with some of these postulates that you're putting in your notes. So I gave you these kind of notes templates for you to work with. You do not have to use these. This is just for organization if you want it. You do have to answer the follow-up questions at the end. So I'll go through the notes with you and then you'll have to finish these on your own. So we're talking about postulates and theorems today, and postulates, just a reminder, are statements of fact. They're things that we accept as true. So our first one says a line contains at least 2 points. And we kind of already talked about this with our definitions, but in order to create a line, you need that second point. Just having one point by itself is just an exact location. You need to be able to extend it through something else. So that's why we need at least 2 points. Our second postulate, and remember, everything builds. So we go from a point to a line to at least 3 points, not all in one line, creates a plane. So A and B can sit on the same line, but you need at least one other third point kind of in the distance that will create this extended space that makes a plane. And remember, we draw these kind of as rectangles or parallelograms, but really a plane keeps extending in all directions. So it looks contained, but remember, there are no edges to a plane. And if we go up now, okay, or down or in a different direction, we create space. And space contains at least 4 points, not all in one plane. So see how we're building from a flat line to extending it to the plane, and then we're going three-dimensional and we're creating space. So those are our first 3 postulates. And we'll keep going. Through any 2 points, there is exactly 1 line. Now this looks a little similar to the first postulate we just talked about, but it's actually sort of flip-flopped. That now we have our 2 points and we're saying there can only be 1 line that goes through both of them. And now we start getting a little more complex. Through any 3 points, there is at least 1 plane, and through any 3 non-collinear points, there is exactly 1 plane. So I've got this picture here. These would all be collinear points. They sit on this vertical line going through these 3 planes. And if you think of the walls in your house or the walls in our classroom, those are all vertical planes that meet at the corner, which would be this line. And all of the points on that line are collinear. But if we pick 3 non-collinear points, so pick 3 chairs in your house, there's only 1 plane that they all sit on. And think of it like the first floor of your house. And then if we keep going, we can flip-flop that. If there are 2 points in a plane, then the line that contains the points has to be in that plane also. So if we, again, think of things in your house. If you pick any 2 chairs on the first floor of your house, there's only 1 line that you could connect those 2 chairs with. And that line is also on the first floor of your house. And our last postulate says that if 2 planes intersect, then their intersection is a line. And these are the edges of the corners of our rooms we're talking about, okay? So the vertical planes have this nice clean edge. We could go diagonal. Remember, planes can go in any direction, but if they intersect with each other, they're going to intersect at a line. Okay? So those are our 7 postulates. And then you also have 3 theorems in this section. And theorems are things that require proof. And we'll get into proofs maybe next week. But our first theorem says if 2 lines intersect, then they intersect in exactly 1 point. And we could use our postulates we just talked about to prove this. And we could do that by, if we drew, let me get a few points here, okay? So this says if two lines intersect, so remember I need 2 points in order to create a line. Missed my mark a little bit. Adjust, so here's my first line, and then my second line also has to go through 2 points. There's only ever going to be 1 point where those both meet. Our second theorem says through a line and a point not in the line, there is exactly 1 plane. And this comes back to our postulate here, space contains at least 4 points. So, or you could also reference this postulate. Through any 3 non-collinear points, there's exactly 1 plane. So that also supports our theorem here. And our last theorem says if 2 lines intersect, then exactly 1 plane contains the lines. So if I go back to my crisscross here, there's only 1 plane that exists that will contain both of these lines in all directions. So you've got 7 postulates, 3 theorems, and you have a few follow-up questions here. Name the postulate that shows each statement is true, okay? And they don't have names specifically. You could number it with whichever one you're answering with, or just write out the postulate. I think that's a better rule of thumb. We'll get to more of that later. And you have to, for these, decide if each statement is always true, sometimes true, or never true. So 3 points determine a plane. Is that sometimes, always, or never true? So finish up with these in your notebook. You're going to have some application work in the textbook as well that is posted in the assignment post on Schoology. And you can always go back and watch this video again if you need to see any of the diagrams or the visuals. Sometimes it's hard to imagine them when you're just copying the words. So give yourself a sketch for some of them, especially if you're having trouble envisioning like intersecting planes. I think that's a hard one sometimes. All right. So good luck with the application and practice work. Email me if you have questions, rewatch the video if you need to, and I will see you guys in class.